Hey everyone, and welcome back for another deep dive. Today we are going all the way down into an oil well to explore something called skin factor.
Skin factor.
Yeah, have you ever heard of that?
Oh, yeah. Skin factor is a very important concept in oil and gas production.
And it's something that I think a lot of people, even if they're familiar with oil and gas,
Mm.
they might not really know too much about it. So I think it'd be great to just break that down. Like, what is skin factor for someone who's never even heard of that term before?
Yeah, so you can think about it this way. Imagine you have a pipe and water is flowing through that pipe. If there is some buildup inside the pipe, that buildup is going to resist the flow of that water, right?
Right, it's going to slow it down.
It's going to slow it down,
Right.
exactly. So that buildup is kind of like the skin and the resistance to flow that it causes. That's the skin factor.
Okay, so it's like a clogged pipe.
Yeah, exactly, like a clogged pipe. And just like in a pipe, the smoother the flow, the more efficient it is. In an oil well, a low skin factor means the oil can flow more easily from the reservoir into the well.
That means more efficient and profitable oil production.
Exactly, you got it.
Okay, so that's what skin factor is. And we're going to be talking about how they are using machine learning to predict skin factor. And we have this fascinating research paper that goes into detail about that. So we're going to be looking at that paper today and kind of going through it and taking a deep dive into how this technology is changing the world of oil production.
Yeah, this is really cutting edge stuff.
So maybe we can start with, you mentioned how important skin factor is, but what are some of the traditional challenges with estimating this factor? And why is it so tricky to get right?
Well, you see, the underground environment is incredibly complex. It's not a uniform space. It varies greatly from place to place.
Oh, I see.
So every well encounters unique conditions. You have different types of rock. You have varying levels
Right.
of damage that might have happened during the drilling process. And even the geometry of the well itself can contribute to this skin effect.
So it's not just one thing, it's a whole recipe of factors that are impacting the flow of oil.
Exactly. And because of this complexity, pinpointing the skin factor and understanding its impact has always been a challenge.
That makes a lot of sense. So traditionally, how is this done?
Yeah.
Like, how did they try to figure out what the skin factor was?
Well, conventionally, they used methods like well testing, which involves physically going down into the well and taking measurements.
Okay.
It gives you accurate data, but it's expensive, time-consuming, and it often disrupts the production process.
So not ideal.
Not ideal at all. And that's where this research paper comes in. It proposes using machine learning as a more efficient and precise alternative.
So instead of actually going down there and probing the well, we're training computers to sort of crunch the numbers and predict what the skin factor is going to be.
That's the idea. They're leveraging the power of data analysis and algorithms to predict this crucial factor.
So for our listeners who might not be data scientists,
Yeah.
could you break down how this machine learning thing actually works? Like, what's the basic concept here?
Sure. So at its core, machine learning is about training computers to learn from data. In this case, we feed the computer a massive amount of data about different wells, including their skin factors and all sorts of other relevant information.
Okay.
The computer then analyzes this data, identifies patterns and relationships, and builds a model that can predict the skin factor of a new well based on its characteristics.
So it's kind of like giving the computer a textbook on well behavior
Yeah.
and then testing it on a pop quiz.
Yeah, that's a good analogy. The more data we feed it, the better it gets at predicting.
That's pretty amazing. And this research paper that we're looking at today, what makes it stand out in the world of machine learning and skin factor prediction?
Well, what's really remarkable about this research is the sheer volume and diversity of the data they used. We're talking about data from over 19,000 data points from something like 1088 wells in Egypt's western desert.
Wow, that's a lot of wells.
It is. And it's not just the quantity, it's the variety. They covered a wide range of, well, types, reservoir conditions, you name it. This allowed them to create models that are incredibly robust and can generalize well to different scenarios.
Okay, hold on a second.
Mm-hmm.
Why is this massive data set so important?
Mm-hmm.
I mean, I get that more data is generally better, but is there something else at play here?
It's all about capturing the complexity that we talked about earlier. Remember how we said that skin factor is influenced by a whole bunch of different things?
Right, the rock type, the drilling
Yeah.
damage the shape of the well.
Exactly. If you only train a model on a small data set, it might do well in those specific situations, but it might completely fail when it encounters a new, unseen set of conditions.
So it's like if you only studied one chapter of the textbook, you might ace that chapter, but you'd probably bomb the rest of the test.
Precisely. By using such a massive and diverse data set, these researchers were able to create models that could generalize well and accurately predict skin factor across a much wider range of wells.
So it's like they gave the computer the entire textbook, not just one chapter.
Exactly. And not just the textbook. They went above and beyond collecting all sorts of parameters that you wouldn't typically consider. They looked at everything from the obvious things like flow rates and reservoir pressure to even the tiny perforations that allow oil to enter the well.
They really threw the kitchen sink at it. So all this meticulous data collection, did it actually pay off? Like, did they get accurate predictions for skin factor?
Oh, the results are impressive. They achieved mean absolute percentage errors as low as 2.9% and correlation coefficients above 0.95.
Okay, break that down for us. What does that actually mean?
It means that these models were really good at predicting skin factor. In some cases, they were almost as accurate as traditional well testing methods, but without the cost and disruption.
So we're talking about potentially saving a lot of time and money here.
Absolutely. And that's what makes this research so exciting. It's not just a theoretical exercise. It has the potential to transform how we manage skin factor and ultimately make oil production more efficient and profitable.
That's a pretty compelling argument for adopting this technology.
Yeah.
But I'm curious, beyond just being accurate, did these models reveal anything new about skin factor?
hmm
Like, did they uncover any insights that could change how we approach this problem?
One of the most fascinating things that came out of this research is how these models handle the interplay of different parameters. Traditionally, we've tended to look at each factor in isolation, but machine learning allows us to see the bigger picture.
You mean how all these different things are working together to influence the skin factor?
Exactly. It's like instead of looking at individual pieces of a puzzle, machine learning can see the whole picture and understand how all the pieces fit together.
And this could lead to more targeted interventions, right? Like if we can see how certain combinations of factors are contributing to a high skin factor,
All right.
we can adjust our approach accordingly.
Precisely.
Hmm.
For example, imagine identifying a specific combination of drilling parameters that consistently results in a higher skin factor.
Good.
With that knowledge, operators could adjust their drilling practices to minimize skin damage before it even occurs.
That's what I call proactive well management. So it's not just about predicting the skin factor, it's about using those predictions to improve our entire approach to oil production.
That's exactly right. It's about using data to make smarter decisions and ultimately optimize the entire process.
This is all very impressive in theory, but I want to get down to brass tacks. Like, how do these models actually perform in the real world outside the controlled environment of research?
Well, they put their best model, the random forest model, to the test on a specific well, which they called Well X. The model predicted a skin factor of 2.7 for this well.
All right, drum roll, please. What was the actual skin factor?
The actual skin factor measured through conventional well testing turned out to be 2.6.
Wow, that's incredibly close.
It is. It really highlights the potential of this technology. To achieve that level of accuracy without any physical intervention is a major breakthrough.
So it's not just a theoretical possibility, it's a practical tool that's ready to be deployed in the field.
Exactly, and that's what makes this research so groundbreaking. It's not just an academic exercise, it's a real-world solution that can make a significant impact on the oil and gas industry.
This has been a fascinating exploration of how machine learning is tackling one of the most persistent challenges in oil production. But this is just the tip of the iceberg. Join us after a quick break as we delve deeper into the world of machine learning and its vast potential to revolutionize the oil and gas industry. I mean, that Will X prediction really shows you what's possible here. It seems like we've only just scratched the surface of what machine learning can do for oil and gas. So where else can we apply this kind of data-driven thinking? What other parts of this industry could benefit?
Oh, the possibilities are endless. Think about it. Every step of oil and gas production, from exploration to refining, generates a ton of data.
So we're practically swimming in data, but the challenge is making sense of it all.
Exactly. We're trying to understand complex geological formations and optimize the extraction process. It's like having this massive puzzle.
And machine learning is the key to solving that puzzle. It can connect the dots and reveal patterns that we humans might miss.
Precisely. A great example is reservoir characterization. Understanding the size, the shape, the properties of the oil-bearing reservoir is essential.
But traditionally, that's been done with seismic surveys and well testing, which can be pretty expensive and take forever.
Yeah, and that's where machine learning can really shine. By feeding it a wide range of data, seismic, data well logs, production history, we can train these models to predict key reservoir properties like porosity and permeability.
So we're essentially creating a virtual geologist that can analyze massive amounts of data and tell us where to drill.
That's the idea.
Yeah.
And with more accurate reservoir models, we can make better decisions about, well, replacement drilling strategies and ultimately produce more oil.
It all sounds great, but I have to ask, wouldn't the accuracy of these predictions depend on the quality of the data we're feeding into the models?
Absolutely. Data quality is paramount. Garbage in, garbage out, as they say.
Makes sense. So data quality is crucial, but let's assume we have good data. What else can we do with machine learning besides reservoir characterization?
Well, another huge area is production forecasting. Accurately predicting how much oil a well will produce over its lifetime is critical for making investment decisions, planning infrastructure, and developing the entire field.
But predicting the future seems inherently uncertain. How can machine learning improve our forecasting ability?
Traditional decline curve analysis relies on these simplified assumptions about how production will decline over time. Machine learning, on the other hand, learns from actual historical production data. It takes into account the specifics of the reservoir, the well itself, and it can spot complex trends and patterns that humans might miss.
So we're moving away from static models towards a more dynamic, data-driven approach.
Exactly. And the more data we feed these models, the better they get.
Okay, so we've talked about reservoir characterization and production forecasting. It seems like we're building quite a toolkit of applications for machine learning in the oil and gas industry. What else can we add to this list?
Let's not forget about drilling optimization. Drilling wells is a complex and costly process, and it can be quite risky.
So how can machine learning help us drill smarter, faster, and safer?
Imagine being able to predict drilling problems before they even happen. Machine learning can analyze real-time drilling data, like drilling speed torque vibration, and detect those subtle anomalies that might signal an impending issue.
So it's like an early warning system for potential drilling hazards.
Exactly. And that allows drillers to take corrective action before a small problem turns into a major disaster, saving time, money, and potentially even lives.
And beyond just avoiding problems, can machine learning also help us optimize the drilling process itself?
Absolutely. We can use it to fine-tune drilling parameters like
Wow.
mud weight and drilling fluid properties.
So we're not just drilling faster, but also smarter and more sustainably.
Precisely. It's all about finding that balance between maximizing production and minimizing our environmental impact.
We've covered a lot of ground here: reservoir characterization, production forecasting, drilling optimization. It seems like every aspect of oil production stands to benefit from this machine learning revolution. Is there anything else you're particularly excited about?
Oh, definitely. Predictive maintenance is another game changer. Imagine being able to predict when equipment is likely to fail and schedule maintenance proactively.
That would be incredible. No more unexpected breakdowns, costly repairs, or production losses.
Exactly. Machine learning can analyze data from sensors and monitoring systems and detect those subtle changes in equipment performance that might suggest an impending failure.
So we're shifting from a reactive approach to maintenance to a more proactive and preventative one.
Precisely. And that not only saves time and money, but also improves safety by reducing the risk of catastrophic equipment failures.
It's clear that machine learning is not just a fad. It's a fundamental shift in how we approach oil and gas production. It's about using data to make smarter decisions, optimize operations, and create a more efficient and sustainable industry.
And what's really exciting is that we're only at the beginning of this technological revolution. As we gather more data, develop more sophisticated algorithms, and push the boundaries of what's possible, the applications of machine learning in oil and gas are practically limitless.
This has been a truly eye-opening conversation. It seems like we need a moment to process all these incredible possibilities. But before we get too carried away, let's take a quick pause and then come back to wrap up our deep dive into this fascinating topic. Wow, I feel like my head is spinning with all these possibilities. It's amazing to think about how machine learning is reshaping the oil and gas industry.
It really is. It's changing how we understand the subsurface and giving us the tools to make better decisions every step of the way.
As we wrap up this deep dive, I'm curious, for our listeners who might be thinking, okay, this is cool, but how does this actually impact the future of oil and gas? What's the big takeaway here?
The key takeaway is this: we're seeing a fundamental shift in how we find, produce, and manage energy resources. It's not just about doing things a little better, it's about changing the whole way we think about the subsurface.
So we're moving away from guesswork and gut feeling and towards a more scientific, data-driven approach.
Exactly. We're harnessing the power of data and algorithms to make smarter decisions, optimize our operations, reduce risks, and ultimately create a more efficient, sustainable, and profitable industry.
This has been a really thought-provoking conversation. I'm already thinking about all the implications. But before we say goodbye, I always like to leave our listeners with something to ponder, a question that sparks more exploration and discussion.
Well, throughout this deep dive, we focused a lot on the technical side of machine learning. But there's a human element that we shouldn't forget.
Yeah, I like where this is going. Tell me more.
The success of machine learning in oil and gas, or any industry for that matter, depends on human expertise. It's not about replacing human judgment, but about enhancing it.
So it's a partnership between human ingenuity and artificial intelligence.
Exactly. We still need skilled engineers, geologists, data scientists, people who understand the data, can interpret the results and make informed decisions based on both data-driven insights and their own experience.
It's a good reminder that even with all this advanced technology, the human element is still essential. We need people who can bridge the gap between data and decision-making, making sure these tools are used responsibly and effectively.
Absolutely. The future of oil and gas is not about choosing between human expertise and AI. It's about finding ways to combine them to get the best of both worlds.
That's a great point to end on. It reminds us that we're all part of this journey of innovation and discovery. And by embracing human ingenuity and technology, we can tackle the challenges and opportunities ahead.
So to everyone listening out there, keep exploring, keep learning, and keep asking those what-if questions. The future of energy is being shaped right now, and we can all be a part of it.
Thank you for joining us on this deep dive into the fascinating world of machine learning and oil and gas. Till next time, keep diving deep.